right, guys, are there any questions on any of the assignments thus far?
The short question number 18.
Okay. On 6-3. Sorry, I'm borrowing a book. .3, problem 18. Evaluate the following logarithm. Log base 7 of 49. Now, okay, yes. So what we can do is we can rewrite this as an exponential, saying that 7 to the y is equal to 49. So we want to determine how many times do I need to multiply 7 by itself to get to 49? 2. Because 7 squared is 49. So the answer for this is 2. Or 7, log base 7 of 49 equals 2. Questions on this here? Any other questions on the homework? Pretty good with this here? And actually, this is a good question to lead into. Now, what we could say, so log base 7, well, we know 49 is 7 squared, yes? So we could rewrite this as log base 7 of 7 squared. Now, looking at the first page of our notes, using inverse properties, by definition of a logarithm, it follows that the logarithm function g of x is log base b of x, and so on and so forth. We have this here. But the key part is this, that log base b of b to the x is x. Log base b of b to the x is x. If the base and what's inside the logarithm are the same, they simplify out. Let's go back to what we just had. Well, we already solved this. We know that log base 7 of 49 is 2. Well, what do we have here? We have log base 7, if I can write in red, not erase, of 7. The base and what's inside the logarithm are the same, yes? So they simplify out, leaving us with 2. Because when the base and what's inside the logarithm are the same, they simplify out. Now, when we have b to the log base b of x, b to the log base b of x, those will simplify out as well. So if the base, or what we have, the log 2, and the base of the log are the same, they will simplify out. They will cancel out as well, or they will, as I say, undo each other, because the logs and these exponentials are inverses of each other. They will undo each other. Let's look at the first one of these two here. We have 10 to the log of 4. Now, I didn't specifically state this on Thursday. Not Thursday, it'd be Wednesday. Whenever a logarithm does not have the base written, it's actually understood to be 10. This is considered the natural, or the common log. Common log would be base 10. But in this example here, the base and what this is being put to are the same, which means these here will simplify out, leaving us with 4. 10 to the log base 10 of 4 is going to be 4. And we can actually see this in a calculator. We can clear that out. So what we can say is 10 to the log of 4 is 4. They will undo each other. They undo each other. And we can plug most of these in as long as there's not any variables. It's with both of the calculators that we can use on standardized tests, they don't allow for the use of variables. Any questions on A, how we got to 4? Now let's look at B. Now this would be nice if I had log base 5 of 5, because if the base and what's inside the logarithm are the same, they simplify out. Now can I rewrite 25 as 5 to a power? Yes, it would be 5 squared dx. Now before we finish simplifying, we do need to kind of simplify our parentheses. This powers of powers multiply, so we're really just saying that we have 5 to the 2x. We didn't necessarily need to write that step, especially if we understand that 25 is going to be 5 to the 2x, that 2 and x will multiply. We could have gone straight there. Now, well, the base and what's inside are the same, so they will simplify out, leaving us with 2x. So log base 5 of 5 to the 2x simplifies to 2x. And part of this deals with the properties of exponents and the fact that log base 5 of 5 is 1. Questions on this here? So what would happen if I try to simplify 10 to the log of 18? What would we get? 18. Because even though it's not written, it's understood that the base for this is 10. So log 10 to the log base 10 of 18, base and what we put it to are the same, so they'll simplify out, leaving us with 18. Well, we can rewrite 16 in several ways, but one of the ways that we need to use is rewriting 16 as 4 to a power. So it's going to be 4 to what power? Squared, yes? We can just say 2x. Because we could have rewritten this with 2 or 4 squared in parentheses to the x, and we know powers of powers multiply, which would have gotten us back to just 4 to the 2x. Whenever we just have that single term, it's not too bad to make that jump, but if it had been like x plus 4, it would have been good to go through the steps because that 2 would not have been multiplied just by the x, but with every term in the exponent. Now what will this simplify to? 2x. Now obviously for these here, they're not all going to simplify to 2x, it just worked out coincidentally that these two here did. Any questions on this here? We good with all these so far? Let's look at the next 4. So if we want to simplify 8 to the log base 8 of x, we get x. Log base 7 of 7 to the negative 3x is negative 3x. Okay, well, we'll need to rewrite 64 as 2 to a power. And indeed, it would be 6. And we could do that by either just doing 2 times 2 times 2 and multiplying 2 by itself until we get 64, and it would take 6 times. Or we can just try numbers, so 2 to the 5th, 2 to the 6th, 2 to the 7th, and see when we get 64. Now we have log base 2 of 2 to the 6x, and this would simplify to 6x. And last but not least, e to the ln of 20 is going to be what? What is the understood base with the natural log? It's understood to be e. So we're saying e to the ln base e of 20. The base and what we put it to are the same, so they simplify out, leaving us with 20. Questions on this here? And this property that we're using here is actually very nice and very helpful, especially once we get to solving. And we'll see it here in a minute, exactly how this works with some other properties. Any questions on what we've done so far? Finding the inverse. The exponential and logarithmic functions are inverses of each other. So y equals b to the x, its inverse is x is equal to log base b of y. Now when we do this here, our final function won't be x equals, so it will be y. Because whenever we solve these here, one of the first few steps or last few steps, depending on where we do this, we have to switch the x and y for the inverse. So in the general example that we have written here, they didn't switch x and y. That's why y is on the inside and x is on the outside. Now if I want to find the inverse of f of x equals 6 to the x, when we did inverses before, well, I'm going to need to rewrite f of x as y. Now the next step we had in writing inverse or finding the inverse function was to switch x and y. So x is equal to 6 to the y. Now if I rewrote this as an exponent or as a logarithmic, it's already an exponential form. I want to rewrite it as a logarithm. How would we rewrite it, or what would it be rewritten? We have log what? Base 6 of x is equal to y. Now, again, it's very tempting to want to say y because, again, in our general form it is y, but we had switched the x and y's location. That's why x is inside and y is on the outside. So this here is the inverse. This is the inverse function of y equals 6 to the x. Now we can see this, and I can show this graphically. So we can say 6 to the x, clear this. So 6 to the x, I think I just said 6x, I did. A little bit different function. 6 to the x is this one here in blue. Now I went on and put the red one in there, y equals x, because any function that is an inverse will be reflected across this line. We can do green. Math. Log base 6 of x. And if we look at this graph, it is reflected across that line, y equals x. So they are inverses. These two functions would be inverses of each other, and we can see this graphically. Any questions on any of this here? Now let's look at the next one. Y equals ln of x plus 3. Now nicely enough, they didn't write this one as f of x. They already have it as y. So we don't have to rewrite it f of x as y. But the first thing we can do is switch x and y. So we say x is equal to the natural log of y plus 3. So what would we do, or how would we rewrite this as an exponential? Because we would have e to the what? X is equal to y plus 3, because we're going off the fact that y equals ln of x if and only if e to the y is equal to x. And is how we rewrite this and how we switch this between one and the other. And we went over this on, what would have been, Wednesday? But is y by itself for this function here? Well, no. If it was, we'd have been done. But since it's not, we have to subtract 3 from both sides, telling us y is equal to e to the x minus 3. And that's it. Questions on this here? Questions on anything we've done so far? Okay. Now this is this is useful knowing how to switch between one and the other. Now what did we just say about the log and its base? If the base and what's inside the logarithm are the same, they simplify out. They simplify to 1, yes? So I'm just going to look at y equals b to the x. Well, if I take this and apply log base b to both sides, let's go like this. This side over here, log base b of b to the x is going to simplify to what? X. Yes? The other side, I can't simplify that any further. We have log base b of y, yes? And that's just using the property that we got today, yes? I'm going to go back a slide. We said y equals b to the x if and only if x is equal to log base b of y, yes? Didn't we just get there using this property we got today? That's why this works. That's why we can switch from one to the other, because of this property. So we can actually use that. Prefer not to write in a highlighter. So we'll need to rewrite this as y equals. And we can use this in finding the inverse or switching from exponential to logarithmic or logarithmic to exponential. Now, again, with finding the inverse, we do need to switch x and y. Now, for this one here, if I want that to simplify out or rewrite it as a log, I'm going to use log base what? 11. Because, again, our base, the number that we have to the exponent, is 11. So we can say log base x is equal to log base 11 of 11 to the y. We can apply this log base to both sides. And the reason that this is nice is because on the right-hand side, we have log base 11 of 11 to the y. And that will simplify to what? Y. The other side will have log base 11 of x. Y is by itself. Well, that's the inverse. That's all we have to do for this here. Questions on any of this here? Any questions on A before we look at B? Now, B is already in exponential or logarithmic form. So log base B of B doesn't really work here, but we did say B to the log base B would simplify. So if I apply or put both of these to the base of whatever that logarithm has, then it would simplify out. Now a natural log's base is what? E. So E to the ln, as we've seen already, would simplify out completely. But what I do to one side, we would have to do to the other. Now, again, we'll need to switch x and y here in a minute, because again, with inverses, we'll have to flip it. And I did this last hour too, forgot to flip it first, but we can do that later. Here, we would get e to the y equals, well, these will simplify out, they'll cancel out, leaving us with x plus 6. Essentially, we're applying what we just got to make these a little bit easier to work with. Now here, to get x by itself, which will be y when we flip it, we need to subtract 6 from both sides, telling us that e to the y minus 6 is equal to x, or for our inverse function, y is equal to e to the x minus 6. Questions on this here? Do we like this property a little bit better than just using the flip or change? Are you ready for the next two? I think they're the last two. So the next one we have is y equals 4 to the x. So the first thing we need to do, and I need to try to remember, is that we do need to switch the x and y. So x is equal to 4 to the y. Now doing the switching, just changing from natural log or exponential to logarithms or logarithms to exponential, works just fine. Or we could do our log base. Which one do we want to do here? Which one do y'all like better? Y'all like applying the log base? So if we, well, okay, well we can do both. So if I applied log base, we'd have log base what? 4 of x is equal to log base 4 of 4 to the y. Now log base 4 of 4 does simplify out, leaving us with just y. On the other side, we would have log base 4 of x, and that would be the inverse. Because if we use the switching method, it's just saying x equals 4 to the y, so log base 4 of x equals y. Same process, we get to the same answer. Any questions on number 17? Let's look at the last one, number 18. Y equals the natural log of x minus 5. So if we switch our x and y, we'll say x is equal to the natural log of 5 minus y. Then what can we do next? We can flip x and y. Yes? And then e. Since ln and e simplify each other out, we can apply or put both sides to the base of e. Because e to the ln of y minus 5, e and ln will simplify, leaving us with y minus 5. On the other side, we'll have e to the x. And last but not least, we would add 5 to both sides, telling us y is equal to e to the x plus 5. And that's it. Questions on any of this here? And really what we're doing here is what kind of the steps that we would actually go about solving, using this e or base and log base to solve. Now this here is just a way for us to see that log base in our exponentials or the natural log and having base e are inverses of each other because they are reflected across the line y equals x. But that is it. That's all we're doing for today, and that finishes up 6.3. Now tomorrow and Wednesday we're going to be going over 6.5. 6.51 and 6.52. On the board, it will say that they both have an assignment. If you look closely at the assignment that's posted for each one of those, you'll notice that it's the exact same thing. We're going to go through the section tomorrow twice, just so you get a better understanding of what we're doing. It can sometimes seem a little complicated of what we're doing because we're taking these logarithms and expanding them and putting them back together. That's it. Now, Thursday will be 6.61, solving these logarithmic exponential equations. We're going to start solving, mainly dealing with something we call one-to-one, making them the bases the same or the fact that the logarithms are the same and solving from there. However, I will not be here Thursday. So I will have a video attached to that. I don't like doing this, but with how everything's going, I don't want to push the test back any farther than what it is. Because at this point here, we're looking at the test being Tuesday of the last week. If I didn't put that assignment or chapter there, we would end up having to do that on Monday, which would mean 662, 663, and 664 would push us all the way to Thursday, which means the makeup day would be Friday of next week, which means Monday would be your review, Tuesday we would go over it, and then Wednesday would be the test, leaving you Wednesday, Thursday, Friday, 3 days to try to get that in. I don't feel comfortable pushing it back that far. So there will be a video attached to that there that you'll watch and do the assignment.